Is on rational functions. Rational functions. Okay. So, rational functions. What are rational functions? Well, rational means like comes from the word ratio. So it's fractions. So it's fractional functions. So rational really represents fractions, fractional functions. So it's a fraction where the numerator and denominator are both polynomials. So a rational function is a fraction where the numerator and denominator are polynomials. Okay. The ones that you see here, let's put 8.1 here and let's look at a bunch of examples. Everything you see on there are examples, right? So we see 9 over x. That's a fraction where the numerator and denominator are polynomials. We see x over 5. Another case, right? So these are just really simple cases. Remember that the 9 by itself is a polynomial. The x by itself is a polynomial. And then, of course, they get a little more complicated, like x plus 4 divided by x minus 9. That's a rational function. Or even more complicated, x minus 3 all over, where are we? I lost it. X minus 3 and then 6x squared plus 7x minus 20. So any type of situation where we have a fraction and the numerator is a polynomial and the denominator is a polynomial, you got a rational function. Good? That's just what a rational function is. The first thing we're going to do with rational functions is to find domains. Okay? So what is the domain of a rational function? The domain is the set of values that you're allowed to evaluate that function at. Okay? So the domain of a rational function, the domain is the set of values that you're allowed to evaluate. So all the numbers you can plug in and get a valid answer. Okay? So for example, let's look at something like x plus 4 divided by x minus 9. Let's say this is my rational function. Then I can ask you to evaluate this at lots of different numbers. Let's just throw some examples on here. Let's create a nice happy table here. X and f of x equals to x plus 4 over x minus 9. So we can plug in lots of different values, like let's say x equals to 4. Then we can put f of blank equals to blank plus 4 over blank minus 9. So that could be a 4 there, a 4 there, and a 4 there. So this will simplify to 8 over negative 5. Okay, well, my point in this is that it's an answer. It's a valid answer. There was no weird things that happened, so everything is fine. We can plug in a 1, we can plug in a 0, we can evaluate it at almost any number, except there exists values, or at least one value, where we end up getting a 0 in the denominator. And as we all know, we're not allowed to divide by 0, right? So that causes a problem. So if we try and plug in a 9, evaluate this at f of 9, f of blank 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 plus 4 over blank plus minus 9. Put a 9 there, put a 9 there, put a 9 there. That's going to cause a problem, right? We're dividing by 0. We're not allowed to divide by 0. This is like 13 over 0, which is undefined. Not allowed, right? Good? Okay, so finding the domain, whenever they ask you the domain, really boils down to find the ones, the values that are going to give you a 0 in the denominator, and then everything else is okay, right? So once we find the ones that produce a 0 in the denominator, those are the ones we're not allowed to have. Those are the ones that cause a problem. Therefore, the rest are okay. Does that make sense? Good? Yes? So back to this thing. If this thing says find the domain, then I'd say the domain is all real numbers except x equals to positive 9. X equals to positive 9 is the only one that doesn't work. Good? Questions, comments, issues? No? Okay, well some of them are really easy, like this one. You know, what causes a 0 in the denominator? It's an x equals to 9. That causes a problem. On the other hand, if we had something a little bit more complicated, say like number 12, this is chapter 8.1, number 12. What if the function was x plus 4 all over 5x minus 7? This one's just a little bit harder, right? That one you didn't really have to do much work. You can just kind of look at it and know that the answer was 9. But this one just takes a little bit more work. We have to think about it. Can you tell what it is? What's going to give me a 0 in the denominator? Well, if we can't figure it out, then what do? We use our awesome algebra skills. We want to know what value of x equals 0. So why don't we do some little side work over here? Little side work. And just focus on the denominator. So set 5x minus 7 equal to 0 and solve for x. Good? Yes. So what's the first step we do then to solve there? Move this guy down a bit easier. Add 7, divide by 5. So 5x equals to 7, x equals to 7 divided by 5. So that's the value, right? So that means that if I came over here and I tried to evaluate this, f evaluated at this number, plus 4, 5, something, minus 7, put a 7 fits there, put a 7 fits there, a 7 fits there, oops, 7 fits there. So if we focus on the denominator, then I know the 5's cancel. And then I end up with 7 minus 7, which is a 0. So the whole denominator goes to 0. I know the whole thing is going to be undefined. Not allowed, undefined. Who cares what the numerator is? I don't even bother adding the numerator because I don't care. I'm dividing by 0. I know it's undefined. Good? And it's the only number that will do that. I know that because I did my little side work and this was the only value that will do that. Therefore, what's the domain of this function? All real numbers except this one, right? So the answer to this one, the domain is all real numbers except x equals to 7 fifths. Any questions? We're good? Good. Okay, let's do one more that's a little harder. So what if the function say number, how about number 22? X minus, no, x plus 6, x plus 6, 3x squared minus x plus 4, and then there's this minus out here. Yeah? Okay, so find the domain is the question. Find the domain. So, we focus our attention on the denominator. That's what we care about. Maybe a little side work here. Side work. We want to figure out what value of x gives me a 0, if any. X squared minus x plus 4. So we set it equal to 0, and we want to solve for x. Let's figure out what are those values. What are the numbers that give me a 0? So how do we factor that? We got to factor it so we can solve this, right? This is going to be one of the AC method ones, right? So this fits the form. This fits the form ax squared plus bx plus c equals 0. So we got a couple choices. We could try and factor it, or we could also use the quadratic formula, right? We can factor it, and one of the ways to factor it is the AC method, right? So factoring it means that we rewrite it as a multiplication of two polynomials, and then we were able to break each one of them down by setting each one equal to 0. That's kind of like the long way, the hard way. And then if you're allowed to, then you can just take advantage of the quadratic formula, right? That's what the quadratic formula is made to do, to solve exactly this thing, when a quadratic is equal to a 0, right? Okay, so let's factor it though. This one's not that hard to factor, and we need to practice anyway. So this is an AC method kind of question, which coincidentally, the AC method is just one way to factor things. It's one method that I presented to you guys. But if you already have your own method, your own ideas on how to do it, and it works for you, then that's fine. I'm not trying to reinvent the wheel. I was just giving one method for people to do. So the AC method is going to be, so this fits this form where A equals to 3, B equals to -1, and C equals to +4. So the AC method, step number 1, AC method. Step number 1 is to multiply the A and the C, which is 3 times 4, giving me 12. Step 2 is I need to find two numbers that multiply to 12, but add the middle one. Oh, that's going to be like pretty much. Something is off. Did I do something weird? Two numbers that multiply to 12, but add the -1. We tried 6 times 2, okay, but they don't, even if we make one of them negative, they'll add up to like -4, +4. That's not going to work out. The 3 and the 4, 3 and 4, they multiply to 12. Or if I make them positive negatives, they'll add up to 1, but they'll multiply to -12. So that's weird.
Isn't it that you're supposed to have the 4 equal to 12 or something? Because that's supposed to be the product. The product should be 4, not 12.
The 4 should be 12. What do you mean?
Well, like
Here?
up here, yeah, this one.
Here? Yeah.
Yeah. Should that not be? Should that be 4 instead of 12? Like, aren't you supposed to try to get it to be equal to 4?
It's equal to 12 when we have a number there. It's just equal to 4 when there's a 1 there.
Oh, okay.
Right, which is the same thing, 1 times 4. But if there's a nice happy 1 right in there, then things work out nicely. Okay, so something is weird. I can't see. Any ideas? Any other ideas that I'm missing? No? So what are we thinking of this might be? All right, well, I give up. I'm a quitter. Why don't we go to the quadratic formula, right? So if you can't think of it right away, don't waste too much time, especially on a test. I don't know, is it 12 and 1, 4? Maybe it's something different. So let's go to the quadratic formula. And what's the formula for that? X equals -b plus or minus square root of b squared minus 4ac all over 2a, right? And then here are the values a, b, and c. All right, so b was the opposite sign of b, so it'll be -1 plus or minus the square root of -1 squared minus 4 times a, which was a 3, times c, which was a 4. Oh, I see what's going to happen. Okay, so what's going to happen inside the radical here? That's going to be 1 minus 16 times 3, which is 1 plus or minus the square root of 1 minus 48. All over 6, which is -47. Uh-oh. What do we do when we have that? -47 inside the root. Imaginary, right? So this is going to become an I. X equals to 1 plus or minus square root of +47, but then we have an I out here divided by 6. Okay. So what can we conclude about this guy way back over here then? the x values that give you a 0, the x values that produce a 0 are both imaginary, right? We can write it this way or we can write it this way. The x values are 1, we can write this, we have a 1/6 plus square root of 47 over 6I, comma 0, one of them. And then the other one is 1/6 minus square root of 47 over 6I, comma 0. Here's the other one. Right? So one with the plus and then one with the minus. But they're both imaginary. So going back to the original question back over here, they didn't really ask us to figure that out. They just asked us what's the domain, find the domain. So the domain is all real numbers, right? Any real number is perfectly okay. The only ones that cause problems are those two imaginary ones over there. But they, as far as the real number system is concerned, all real numbers are okay. All real numbers. Got it? Good? Questions? Consider this one. If this one's giving you like a weird little thing, consider this one. What if we have this? Here's a quadratic. What if the denominator was just x squared plus 1? Let's say the numerator was just like, x up there. What numbers would cause a problem? Well, because you're squaring it, you're always going to get a positive answer, right? Whether x is positive or negative, after you square it, it's always positive. And then you're adding 1, so you're never going to get 0. Right? So here's another case where the answer is all real numbers. The only way that you can possibly have a problem here is if there was a number so that if you squared it, the answer was -1. Right? That would be the place where this would be a problem. And what kind of number is that? Well, that's the definition of an imaginary. I squared is -1. So I, an imaginary value, would be the one that would cause a problem here. But as far as the real domain, a real number system goes, any real number is fine. Okay? Good. Questions? No? Okay. So that's one thing we're going to do with these things is to figure out domains. So asking a domain means we're going to focus on the denominator, figure out what values of x produces 0, and the domain is all numbers except the ones that produce a 0. Good. Another one with domains, or move on? What do you think? Anybody? You're good? I don't want to bore you. You're okay with domains? Move on?
Wait, before you erase it.
Anybody else? No? If you can't keep up with the writing there, I'm going to put this video online, so you can always just go back to it. Okay? We're good? Okay, so nobody wants to know another domain. Let's move on then. The other thing we want to do with rational functions is to reduce them. So to reduce them, let me remind you what happens when you have numbers. Let's say that you were asked to reduce, 45 divided by, 100. Something like that. Well, let me do it the long way, the technical way, and then we'll look at a bunch of shortcuts that people take. They're all perfectly valid. So the more, formal way to do this would be to find the prime factorization of each one of these. That would be 5 and 9, which is 3 and 3. And then find the prime factorization of 100. So 100 is 2 times 50, which is then 2 times 25, which is then equal to 5 times 5. Okay, so the 45 is really a 3 times a 3 times a 5. And the denominator is really a 2 times a 2 times a 5 times another 5. Okay. I'm going to insert an extra times 1 here. So let's do every step here. This would be 3 times 3 times 5 all over 2 times 2 times 5. Let me make this space over here. Times 5 times 5. So what I'm going to do is I'm going to introduce an extra 1 in here. I think that's okay, right? I can always multiply by 1 and not change anything. So I just introduced it in there. All I did is introduce an extra one so that there are 4 numbers on top and there are 4 numbers on the bottom in the numerator and in the denominator. And they're all being multiplied. So what I can do is separate them into separate fractions like this. This would be 3 over 2 times 3 over 2 times 5 over 5 times 1 over 5. So now I have a multiplication of 4 separate fractions. Remember that when we multiply fractions, we don't need a common denominator or anything. We can just multiply straight across the bottom, straight across the top, straight across the numerator, straight across the denominator. So usually we go that way. I'm just kind of breaking it down this way. And the reason I did that is to get to this point where we have a fraction where the numerator and denominator are identical. And whenever we have that, that is a new version of 1. Good? New version of 1. So I can rewrite that guy right in there as 3 over 2, and then another 3 over 2, and then this guy is just a 1, and then a 1/5. And 1 times anything is that same number, so I can go over here and rewrite this as 3 times 3 times 1 all over 2 times 2 times 5. And so what survives in the numerator is a 9 times 9 times 4 and 5 makes it 20. Okay, obviously really long. It's not the way we normally do it. This is just the more formal way of reducing fractions. Let's go at a more common way of reducing them, or the writing that most of the time people put. Maybe they still kind of maybe write down the factorization this way. The 45 is really a 3 times a 3 times a 5 all over the 100, which is really equal to 2 times 2 times 5 times 5. And then they do this thing. Instead of breaking it down into fractions this way, doing all that work, they just go like this. They cross out that 5 and they cross out that 5 right there. Right? And in crossing it out, we're noting that I could do that. I can separate it. I can rewrite it as a 5 over a 5, which is another version of 1. So when we cancel them this way, we're just acknowledging that that's another version of 1 and that everything else survives. So we end up with a 9 over 20. Right? Well, okay, some people might even notice that the only thing they have in common is 1 copy of 5. So an even shorter or faster way of writing this is just to write it as 9 times 5 over 20 times 5. And then notice the 5s are there. And so these guys become 9 over 20. So even faster. And then even faster than that is people that do this. They have this and they go, 5 goes into 45 9 times. And 5 goes into 120 times. And then that's how they get the answer, 9 over 20. Right? So they kind of do that in their heads. So when they're easy numbers, this is really great. But as they get more complicated, I would recommend one of these options here, depending on which one you feel more comfortable with. And these are the options we're going to use to model our case right now. So we're going to be working with polynomials. We're going to factor them as much as possible. We're going to find the factorization of our polynomial in the numerator, factorization of our polynomial in the denominator. We're going to cancel them out whenever we have a new version of 1. And then whatever survives, we're going to multiply. Right? So this is kind of the model that we're going to follow right now with rational functions. Everyone clear on that? Yeah? All right, so let's find one. Do we want to start with a medium one or jump to a hard one?
Hard one.
All right, hard one. How about number 48? Okay, so it says reduce. Let me get rid of this guy here. So this is 8.1, number 48, and it just says simplify or reduce. That's what we have to do for that one, right? So number 48 has 25x cubed minus 75x squared minus 4x plus 12 divided by x squared minus 4x minus 3. F of x equals to that. Guys, can we stop in the back and kind of mumbling around? All right, so the numerator, we have to factor that. So 4 terms, factor by grouping, right? In fact, it's nice to organize this way. I'm going to go off to the side and figure out what those things are. So over here on the side, I'm going to work with A. So I want to factor 25x cubed minus 75x squared minus 4x plus 12. And there's nothing that they all have in common, right? There are no common terms to all four terms. So factor by grouping is our next factoring technique that we want to apply. Let's focus on those two. They have a 25x squared in common, resulting in an x minus 3 plus blank copy x minus 3. And now what do we fill in the blank there to get a true statement? Blank times x equals negative 4. Negative 4. And negative 4 times negative 3 equals to positive 12. So that works out. Next, factor out the x minus 3, resulting in 25x squared minus 4. And then when we get to this point, we realize that this guy factors some more. Right? So this guy factors as x minus 3, and this is a difference of squares. This is 5x squared minus 2 squared. So this is going to be x minus 3 times 5x minus 2 times 5x plus 2. Good? Questions, comments, issues? Good. Okay, so that was just for A. Now we also have to factor B, the denominator. So here we get x squared minus 4x minus 3. So this is the fourth factoring technique. We need to find two numbers that multiply to negative 3 but add to negative 4.
It's plus 3 now.
Oh, did I mess up?
48,
Yes,
right?
48, yes, thank you. Plus 3, plus 3. That might help. So they multiply to positive 3, but they add to negative 4. Multiply to positive 3, but add to negative 4.
Negative 1 and negative 3.
Negative 1, negative 3. Right? They multiply and they cancel the negatives and they multiply to positive 3, but they add to negative 4. So we factored it. So now we can go back over here and rewrite this thing. F of x equals 2. In the numerator we had x minus 3 times 5x minus 2 times 5x plus 2. And in the denominator we had x minus 1 times x minus 3. So we factored everything. We cancel out those guys. And unfortunately nothing else factors. So we're left with what has survived. And our final answer then is going to be equal to this, which is 5x minus 2 times 5x plus 2 divided by x minus 1. And then we FOIL out the numerator again, which we sort of wasted our time then, because I know it's this one. We could have just left it like that, but at that point we didn't know. We didn't know any better. So it's going to be 25x squared minus 4 all over x minus 1. Any questions? No? 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 All right, how about one more? How about 52? Simplify that. Four x squared minus 11x plus 6 divided by 64x cubed minus 27. Simplify that. So we have to factor the numerator, factor the denominator. In the numerator, again, let's put it off to the side and do our work off on the side on factoring. But what factoring technique are we going to have to use there? It's another AC method. So put this A there and B there. Let's go here, A. So this is 4x squared minus 11x plus 6. Now you might want to try the guess and check method for a little bit, see if it works out. If the numbers are relatively easy, it might work out. So there's really only two ways that you can multiply two numbers to get 4. either 2 times 2 or 1 times 4. So that those could be kind of the answers, right? This is one of the methods I think many of you guys probably did in high school. Just fill in blanks and see which one works. Like we could try a 2x there and a 2x there. That might work out. Or we could try 4x there and then just x there. See if that works out. But now we have to play around with the other multiples that give you a 6. So maybe the multiples that give you a 6 are like 1 times 6 or like 3 times 2. So now we got to play around with different possibilities of putting 3 and 2 or putting 1 and 6 or putting it the other way around and figuring out if one of those combinations is the one that works. Right? And we also have to play around with pluses and minuses. Right? Does that sound familiar? Many people did that. Just play around with it. Try different numbers. See which one works. When the numbers are relatively small, this is doable. So if you want to spend a couple minutes trying to figure out which one it is, that's perfectly okay. But I wouldn't recommend that you spend too much time with it, because if the numbers are too complicated, it's ugly. Or it might be something that doesn't even have a solution, and you're sitting there for like 20 minutes trying to figure out how to do it, and it might not have a solution. So it's better to kind of follow the step-by-step process. So once again, this is the AC method, right? That's because the original polynomial here fits the form, the general form of ax squared plus bx plus c, where the role of a is being played by a 4, the role of b is being played by -11, and the role of c is being played by a 6. Okay, so the AC method, step number 1 is to multiply the a times the c, which is 4 times 6, giving me 24. The second part requires that I find two numbers, if they exist, such that they multiply to 24, but they add to -11. Two numbers that multiply to 24, but at the same time add to 11, -11. -3 and -8 multiply to 24, and -3 plus -8 add up to -11. So -3 and -8 are the numbers that work. Now the third step is to go back to the middle value, step number 3, and we're going to replace the b, the -11, with the two numbers that we just found. So we can go back up here, we're going to write 4x squared minus 3x minus 8x plus 6. Right? So the -11 has been rewritten as -3 minus 8 instead of just -11. Okay? And then the last step in the AC method is to do factor by grouping. Now we're going to go over here, fourth step. We're going to say this is 4x squared minus 3x minus 8x plus 6. The first three terms have an x in common, giving me 4x minus 3 plus blank copy 4x minus 3. Right? So plus blank, copy that one. And now fill in that blank by looking at the last two. What do we have to put in that blank to make this a true statement? -2, right? -2 times positive 4x gives me -8x. -2 times -3 gives me positive 6. And now we factor out the common binomial of 4x minus 3, resulting in x plus -2 or just -2, either one. Okay, so that's how we factor the numerator. And if we go back to the guessing and checking method, it looks like it would have been this one, and then the choices of 3 and 2 right here, 3 and 2. And then, both of them were minuses. So you can rewrite this as 4x minus 3 times x minus 2. So the guessing and checking would have eventually led to the right ones. Any questions so far? Okay, so now we still have to factor the next one. So for part B here, part B, how do we factor 64x cubed minus 27? Yeah, this is one of our patterns. This is the difference of two cubes, because I can rewrite that as a cube, I can rewrite that as a cube. So this is really 4x parentheses cubed minus 3 cubed. Right? Something cubed minus something cubed. And if we remember our pattern was this. A cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. Okay, so we have this thing, so we can rewrite it this way. So that means that this is going to be equal to 4x minus 3 and 4x squared plus 4x times 3 plus 3 squared. Good. And now I can just simplify this a little bit and get 4x minus 3 times 16x squared plus 12x plus 9. So that's how we factor the denominator. And this will not factor any further. Right? It's tempting. It looks like it might. There's something squared there. There's something squared there. Obviously, that's how we created it. But it's missing a crucial value of 2. Right? This looks a lot like this one. Remember, if we had a plus b squared, this is equal to a squared plus 2ab plus b squared. This guy right here looks a lot like this, but it's missing this 2 right here. It doesn't have it. So it's not equal to this, and it doesn't factor that way. Right? There's no way to insert it. We can't just insert a 2 in there. So if this had been 24x, we'd be in business. This guy factored if this was 24 in here. But it's not. It's just a 12x. So we can't do it. Is that clear? Okay, so now back to the original question. These are really long questions. This chapter has very long questions, so spread out your work. You're going to use a lot of paper in this chapter. So the numerator ends up being 4x minus 3 times x minus 2, and the denominator ends up being 4x minus 3 times 16x squared plus 12x plus 9. And now this guy and this guy cancel, leaving me just that. So my final answer is f of x equals to x minus 2 divided by 16x squared plus 12x plus 9. Any questions? No? No? Okay, so we can reduce rational functions. What else can we do? Well, we're going to multiply and divide them. Before we do that, let me refresh your memory on what we do when we work with just numbers and we multiply and divide fractions involving just the numbers. So, like, let's say I asked you to multiply 16 over 25 times 30 over 24 times, I don't know, how about 20 divided by 15 times, how about a 12 divided by 36. Nasty looking thing, especially if there was no calculator. Find the answer to that guy right there. Oh man, what would you do? You'd have to like multiply 16 times 30, get an answer, and then you'd get that answer and multiply it by 20, and then get that answer and multiply it by 12, and that's your numerator. And then the denominator, you got to multiply 25 times 24, then get an answer, multiply by 15, then multiply by 36, get an answer, and then here's the worst part. Now you have a ginormous number divided by another ginormous number, then you got to reduce them. So it's just really, really nasty to do it that way. So instead of multiplying first, why not find the prime factorization of all of them, and then cancel, and then multiply. So just doing it in this different order. So that's what we're going to do here. Let's find the prime factorization of all of these. The 16, for example, is really a 2 times an 8, which is really a 2 times a 4, which is really a 2 times a 2. So the 16 is really 4 copies of 2. I can rewrite this as 2 times 2 times 2 times 2. The 30 is really a 5 times a 6, which is really a 2 times a 3. So that one is 5 times 2 times 3. Well, this one's easy. 5 times 5 is 25. And 4 times 5, so that's really like a 2 times a 2 times a 5. This one is 3 times 8. And then the 8 is really 2 times 4 and 2 times 2. 15 is 3 times 5. 36 is like 6 times 6, but each of those 6's is like a 2 and a 3. Right? This guy is 6, this guy is 6. Together then you get 36 times 6 times 6 is 36. And then 3 times 4, which is really 2 times 2 times 2. Good. Any questions on any of those? How they got broken down? All right, it's kind of messy right now, so I'm going to rewrite the whole thing. The first one is really 1, 2, 3, 4 copies of 2. 5 times 5 times, and then 5 times 2 times 3, all over 3 times 2 times 2 times 2, times 2 times 2 times 5 divided by 3 times 5, times 3 times 2 times 2, divided by 2 times 3 times 2 times 3. Okay. Long, nasty thing there. But now we get to cancel a bunch of stuff. That's the fun part. So whenever there is a number in the numerator that's also in the denominator, then that's another version of 1. So this 3 and that 3, and then this 2 and that 2, and then this 2 and that 2, this 5 and this 5, this 3 and this 3. There's a 2 there, and a 2 there, and a 2 there, and a 2 there, 2 there, and a 2 there. And a 5 there and a 5 there, and that's it. Up in the numerator, the only thing that survives is a bunch of 2's. There are no more 2's in the denominator, and in the denominator we only have a 3 and a 5. So what has survived is 2 times 2 times 2 times 2 divided by 5 times 3, which is equal to 16 over 15. Way better than having to multiply the whole thing out and find an answer, right? Okay, so we want to follow the same model this time around with rationals. We're going to be given a multiplication of rational functions, but before you jump into multiplying and getting, your foiling and everything in there, you might want to factor it first, cancel, and then multiply whatever has survived the cancellation. Okay, that's what we want to do. One more thing to remind you of. What if we had division of fractions? How do we deal with like 1/3 divided by 1/2? A fraction divided by another fraction. We rewrite it as a multiplication, right? 1/3 times, and then what would we do there? We flip that, which becomes 2 over 1. And so now this just becomes 2 over 3. Okay. So we write all divisions, a fraction divided by another fraction. We keep the first fraction alone. We don't change it. Then we rewrite the division symbol as a multiplication symbol, and then we take the reciprocal of the second fraction to do that. Good? Okay, so let's look at some of these questions. Why don't we start with something like how about number 36? Divide those two rational functions. (8.2.36). We got x squared minus 6x plus 8 divided by x squared minus 9x plus 14 divided by x squared minus x minus 12 divided by x squared plus x minus 56. Okay, so we have a fraction divided by another fraction. So we can use our little trick. We know that that's going to be equal to the first fraction. Oops. We leave that first fraction alone. We don't change anything. Times, and then we take the reciprocal of this one. So this one gets flipped. X squared plus x minus 56 divided by x squared minus x minus 12. Good? Okay, so now we got to factor everything. This one's not too bad. How do we factor that? We need two numbers that multiply to 8 but add to negative 6.
-4 and -2.
Negative 4 and negative 2 multiply to positive 8 but add to negative 6. Two numbers that multiply to positive 14 but add to negative 9.
-7 and -2.
Great. What about this one? Multiplies to negative 56 but adds to 1.
7, 8, negative 7,
Negative 7 and
oh, positive 8.
positive 8. Right? Because they have to add up to positive 1 and then multiply to negative 56. Then finally, the last one.
Positive 3, negative 4.
Okay, so we rewrite the whole thing then. So then this becomes x minus 4 times x minus 2 all over x minus 7 times x minus 2 times x minus 7 times x plus 8 divided by x plus 3 times x minus 4. Now here's the fun part, we get to cancel stuff. So these guys cancel, they're a new version of 1. This guy and this guy reduce, they're a new version of 1. And finally this guy and this guy cancel, they're a new version of 1. So the only thing that has survived is this guy and that guy. Right? They're the only survivors. Like there's an apocalypse and these are the only people that survived. Out of the rubble come these two. We got x plus 8 over x plus 3. And they don't reduce any further, right? There's nothing to multiply or anything, so we're done. That's it. Good? Questions, comments, issues? No? Sort of, kind of? Easy or harder?
Easier than chapter 5.
Yes, chapter 5 is definitely the hardest chapter in this book, I think.
Very second.
One more multiplication division or move on? What do you guys think? You want one more super hard or one hard, super hard, or move on? One more super hard, I heard. Okay. How about a combination of ugly things? That should be fun. How about something like number 62? 62. Perform the indicated operation, simplify the results. And it looks ugly, and it's toward the end, so I'm just assuming it's hard. Let's see how hard it is. 8.2.62. We got ourselves 8x squared plus 10x minus 3 divided by minus 2x squared minus 8x times x squared plus x divided by 16x squared minus 1 parentheses divided by negative 10x minus 15 divided by 8x to the power of 5. Ooh, ugly. Ugly looking at least. All right. Well, I can first of all simplify the whole thing by rewriting this as a multiplication question, right? All multiplication. This one's already multiplication, so I can treat this as one single thing, one single unit divided by this. So I know we're going to leave the first one alone and then multiply it by the reciprocal of this one, so we can just rewrite it that way. That could be one way to approach it. Or, if you want to, you could just work with this. Work inside here, factor, cancel, multiply, do whatever you need to do in here. Once you get an answer, then we can multiply it by the reciprocal of this. So either way is fine. I'm going to go ahead and just copy it down and change that into a multiplication. 8x squared plus 10x minus 3 divided by minus 2x squared minus 8x. Times x squared plus x over 16x squared minus 1 times, and then I'm just going to flip this guy over, the reciprocal, like that. Okay, now I want to factor everything. All right, well, a couple of these are easy, a couple of them are kind of hard. I think this one's really the only one that's kind of hard right here, right? That guy? Because it's got an 8 in front. This one's easy to factor, easy to factor, easy to factor, easy to factor. So I'm just going to go over to the side and solve just that one right there, just the one with a star. So over here on sort of little side work here, let's work with this star one. 8x squared plus 10x minus 3. Okay, so again, we could do the guess and check method. Two numbers and multiply to 8x squared. Okay, it could be 1 and 8, could be 2 and 4. And then this is easy as well. There's only a couple of combinations of numbers that multiply to 3, 1 and 3, and then we got to be careful with the signs. So we can kind of guess and check our way through it if we want to, but let's go through a sort of a quicker version of the AC method. People always ask me, do you have to do all that work? Well, no, you just, you do more work in your head, you write down less stuff. So the first step in the AC method is to multiply 8 times negative 3, giving me negative 24. The next step is to find two numbers that multiply to negative 24 but add to 10.
12 and negative 2.
12 times negative 2 multiply to negative 24, but 12 plus negative 2 add to 10. I found them. The third step in the AC method is to replace that middle term. So 8x squared plus 12x minus 2x minus 3. Right, so we replace this middle term right there with that. And now factor by grouping. The first two terms have a 4x in common. And then we get a 2x and a plus 3. Plus blank copy, 2x plus 3. And now what do we fill in the blank with? Blank times positive 2x gives me negative 2x. So it's got to be a negative 1. And now finally we factor that out here. Fourth step, so we get 2x plus 3 times 4x minus 1. So we still did the AC method, I just did less writing, right? Before I put the whole formal thing, this fits the form, a x squared plus bx plus c, where the a is an 8, the b is a 10, the c is a negative 3. So, just a little bit less writing. As you do these more and more and more, you rely on less and less writing, and that's okay, as long as you do a little bit, just on the test, for example, just to show me how you did it. But in a case like this, I would really just accept the answer, because you might have just, kind of guessed and checked your way into it, and that's okay as well. Okay, all right, so back to this guy. Now I know the way that star gets factored. That star there gets factored as 2x plus 3 times 4x minus 1. What about this one? How do we factor this? It has a 2x in common, right? So let's factor out a 2x. And what survives is a
X plus 1. No, plus 4.
4. Okay. We can always double check it. Remember, factoring is the opposite of distribution. So this times this must be that, and this times this must be that. So very often you kind of take a guess and then check it. Oh no, that didn't work out. Maybe adjust it, fix it. Okay, these guys have an x in common, giving me x plus 1. And then these guys, this is a difference of squares, right? Something squared minus something squared. So this factors as 4x minus 1, 4x plus 1. Great. Well, that doesn't factor. That's fine. And then here, again, they have a 5 minus 5 in common, giving me 2x plus 3. Yes? That's going to be negative. That's going to be negative. Okay. So let me recopy all these red things. There's too much stuff happening. 2x plus 3 times 4x minus 1 minus 2x, x plus 4 times x plus 1 all over 4x minus 1 times 4x plus 1 times 8x to the power of 5 all over negative 5 times 2x plus 3. Notice that I stopped writing that parentheses there. It doesn't matter anymore. Why? Because up here, when we had division and multiplication, it was important for us to follow the instructions to take care of this first and then deal with that. On the other hand, now that we have nothing but multiplications, it doesn't matter anymore. Okay, so we don't have to follow the order. It's just a multiplication of 3 fractions. And now we get to cancel stuff. So this guy and this guy cancel, and this guy and this guy cancel, and there's an x right in there that cancels with that one, and that's it, right? So up in the numerator, this thing survives completely, and then this guy survives. In the denominator, we have a negative 2, a x plus 4 term, 4x plus 1 term, and then a minus 5 term. So let me rewrite that. So we're going to have x plus 1 times 8x to the 5th power in the numerator. In the denominator, we have a negative 2 times a negative 5 times an x plus 4 times a 4x plus 1. It's all multiplication, so the order in which you write it doesn't matter as long as you don't forget any of them. We have a negative 2, a negative 5, an x plus 4, and a 4x plus 1. Okay, so this guy we multiply, that's easy, that's just going to be 10. And then this guy we're going to have to FOIL, and this guy we're going to have to distribute. So we end up with, in the numerator, that's easy, that's just distribution. So we'll get 8x to the power of 6 plus 8x to the power of 5. You might actually, I'm going to squeezing it in there, so let me put it here. Okay, so up in the numerator, I'm going to distribute this times this times that. So I end up with x times 8x to the 5th, so it'll be 8x to the 6th power plus 8x to the 5th divided by, and now in the denominator I have a 10, and then I have to deal with this, so I'm going to FOIL this guy out, this times this times this times this times that. So it'll be 10 times, and it'll be 4x squared plus x plus 16x plus 4. Okay, by combining like terms, we get 8. Oh, wait a minute. Something went wrong. I didn't notice that. Let me stop me. There's a 2 there, and then there's an 8 there, so obviously one of those reduced, right? So I missed an opportunity to chop something here. I could have crossed off that 2 and a 2 that comes from that 8. So it's no big deal. I can do it now, but I could have saved myself some work because now I have to do a little bit of work to factor out a 2. So I'll do that now. I'm going to factor out a 2 from the numerator there, so I'll put a 2 there. And then that'll leave me with 4x to the 6th power plus 4x to the 5th power divided by, and then I'm going to leave this again as a 2 times a 5. Well, okay, that's fine. 4x squared plus 17x plus 4. And now these guys cancel. And now I'm ready for my final answer. My final answer is 4x to the 6th plus 4x to the 5th divided by 20x squared. And then 17 times 5 is that 85? X plus 20. That's our final answer. Any questions? No? No? Good? Questions? No? Okay, yeah.
It's another equation. It's not from the book, it's from the homework actually, but it's kind of stuff.
From this sort of thing? Do you have it? Do you know it?
Yeah, it is x cubed minus 64 divided by
Hang on,
x
cubed minus 64.
divided by x squared minus 16.
Okay, and then the instructions say to do what? Simplify?
Simplify the right-hand side of the equation.
Okay, so this should have been kind of like an 8.1 kind of question, right? Because 8.2 is about multiplying and dividing. This one just says reduce or simplify. So the key to it is just to factor it as much as we can and cancel things, right? So how do we factor, let's say the denominator. How do we factor this denominator? Yep, this is a difference of squares, right? So this is kind of like using the fact that we know that a plus b times a minus b is the result of, or when we FOIL that, when we FOIL all that out, we see that we get a squared minus ab plus ab minus b squared. The middle terms cancel, giving us the a squared minus b squared. So therefore, this is one of our little shortcuts that we memorize, that we see when we see something squared minus something squared, we know it factors that way. Well, we also have another little shortcut that we are familiar with, a cubed minus b cubed, right? And that's what we're going to need in the numerator. So the a cubed minus b cubed is equal to a minus b. We used that earlier, didn't we? This one's equal to a minus b times a squared plus ab plus b squared. Okay, so we want to use this pattern to simplify this one, and then use the other pattern to simplify the denominator. So in the numerator, we're going to end up with x, okay, let me rewrite it as x cubed minus 4 cubed, all over x squared minus 4 squared. Right? 64 is really 4 cubed. So now this one follows under this pattern, and this one follows this pattern. So the numerator is going to be x minus 4 times x squared plus, plus 4x plus 16. And the denominator is going to be x minus 4 times x plus 4. Means that this guy and this guy cancel, and then that's our answer right there, right? There's no way to reduce that any further. X squared plus 4x plus 16 divided by x plus 4. And just like we saw earlier, there's this temptation to want to try and factor this thing, but it's not going to factor because it's missing that 2 that belongs there when we're thinking of x plus or a plus b squared. So we're thinking it might be an answer of like x plus 4 squared, and then it would cancel with this one. But x plus 4 would have an 8 in there, right? So it's missing that extra term of 2. Any other questions? No? 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 Okay, so